Welcome to the SICCAR demo showing the tracking, tracing and provenance of a food and drink product in real time. This process engages different parties in a distributed ledger technology network that all need to work together to create an immutable digital record of what has happened to the product to prove its special qualities, yet keep commercial confidence. We are evidencing that oats have been grown and stored in uncontaminated environments and can therefore be assured and certified as being gluten-free. The SICCAR Designer Toolkit sets up the process and the network of the multiple actors building the digital record. The process is created step by step, specifying which data we want to see from which actor, in what order. Here in the Designer, the tree diagram of the process visually and simply represents the logic of the whole process for the provenance and growth lifecycle of oats. It has been designed already, so we will just quickly walk through it. It starts with setting the title and description and then choosing the actors. In this scenario they are the farmer, the verifier and the third-party assurer. We then define the steps in the collaborative process. Each step is given an appropriate name, an actor and a section for the required data. The types of data input are different, so we have predefined inputs such as checkbox, date, single line, etc. A vital part of designing the process so that it is closely controlled is setting permissions for each actor, the organisations in the network, to determine what data they have write and read access to. We can then also set data as public during the design process, meaning it is not encrypted and available to public search. We can then set a unique identifier for each instance of the process. That's the description and the date in this case. We can then click the View Process button to see it diagrammatically. Finally, the process is saved and published. Notified by SICCAR, actors are directed to the SICCAR executor, which are web views where each organisation can see which actions they need to. The farmer starts the process by uploading field history evidence. Note that at this step, the farmer can't edit other fields than those they are responsible for. After the submission of their steps, notification is sent to the verifier to let them know the oats need tested. The verifier can also add data digitally and uploads evidence for their step. All parties build the digital record, following and evidencing only the steps in the process. Here, the previous information provided by the verifier can't be changed by the farmer. It is tamper-proof. The quality checks are reviewed by the third-party assurer and the oats are granted a gluten-free certification. They are notified when they must review the unique quality and can see the documents and data they need to do this. Note that as the quality assurer wasn't granted permission to see all data, they only see what is relevant to them. The end user app is triggered by a QR code being read by the consumer or a food manufacturer who is interested in provable gluten-free status. The app shows just the data from the oats digital record that had the permission to be public. The data specified gives the consumer evidence to prove the gluten-free status of the oats throughout different parts of their life cycle. The digitised record of the physical journey of the oats creates more efficient provenance and life cycle traceability, with each party able to search for and see only the data for which they have an explicit granular permission. The rest of the data, including metadata, is encrypted and not visible without the required permission. The transaction viewer evidences the cryptographic encryption at a granular level, highlighting the security around the digital records for the product, and increasing trust between the different actors as they can see what has happened in real time through the shared but permissioned record. Now all digital evidence in each step is immutable in a shared record, verifying the product's history, and encrypted data is only accessible by actors given explicit permission to decrypt it. Everything else is securely hashed and unreadable. The public data is accessible via a web page available to consumers. From a QR code on the product's packaging, people can see evidence about the oats' provenance, such as where and when they were grown. They can also see public data from the ledger which proves the oats' gluten-free status at different stages in the growing life cycle. such as the field history, evidence that the harvesting and transport machines were cleaned down properly, that the store was gluten-free, and that the final checks were passed.